Hey there, science fans! Today we're diving into the fascinating world of nuclear power plants. They're like giant energy factories, but instead of burning coal, they harness the power hidden inside atoms. Pretty cool, right? Nuclear energy plays a crucial role in meeting the world's growing energy demands. As we move away from fossil fuels, we need reliable and sustainable energy sources. Nuclear power plants provide a significant portion of electricity in many countries. Unlike solar and wind power, which depend on weather conditions, nuclear power plants generate electricity continuously. They're not affected by cloudy days or calm winds. This reliability makes them essential for providing baseload power, ensuring a steady supply of electricity to our homes and businesses. But how do these amazing power plants actually work? Let's find out. Imagine splitting a tiny atom so small you can't even see it. Sounds impossible, right? Well, that's what happens inside a nuclear reactor through a process called nuclear fission. Nuclear fission is like splitting a super concentrated energy ball. When the nucleus of a heavy atom like uranium or plutonium is struck by a neutron, it splits into smaller atoms. This splitting releases an incredible amount of energy in the form of heat and radiation. Think of it like breaking a stick. A whole stick doesn't have much energy, but when you break it, you release a little bit. Now imagine breaking a stick that releases 1,000,000 times more energy. That's fission. This energy release is what makes nuclear power possible. By harnessing the power of nuclear fission, we can generate enormous amounts of electricity from a small amount of fuel. Stay tuned to learn how. Now here's where it gets really interesting. When an atom splits during fission, it not only releases energy, but also more neutrons. These neutrons can then go on to split other atoms, creating a chain reaction. Imagine a room full of mousetraps, each loaded with a ping pong ball. If you toss one ping pong ball into the room, it'll set off a chain reaction, with mousetraps triggering each other and ping pong balls flying everywhere. The chain reaction in a nuclear reactor is carefully controlled using materials that absorb neutrons. This control is crucial for safety and for regulating the amount of energy produced. Too fast, and you've got a problem. By carefully managing the chain reaction, we can harness the immense energy released by nuclear fission to produce electricity. But what kind of fuel do we use for this powerful process? Let's find out. Not all atoms are created equal when it comes to nuclear power. The most commonly used fuel in nuclear reactors is uranium, a naturally occurring radioactive element found in rocks and soil. Uranium is like the super fuel for nuclear power plants. It's dense and packed with potential energy, just waiting to be released through fission. A little bit of uranium goes a long way. Another fuel used in some nuclear reactors is plutonium. Plutonium is created as a byproduct of uranium fission in a reactor. It's like getting bonus fuel from the process itself. These fuels are carefully processed and formed into pellets, which are then loaded into fuel rods. These rods are bundled together and placed inside the reactor core, where the magic of fission takes place. Now that we know what fuels these power plants, let's explore the heart of the operation, the reactor itself. Section 5. Inside a nuclear power plant, from atoms to electricity. The nuclear reactor is the heart of a nuclear power plant. It's where the atoms split, releasing the heat that ultimately generates electricity. Let's take a peek inside. The reactor core contains the fuel rods and is surrounded by a containment structure. This structure is designed to withstand extreme pressure and prevent the release of radiation. Think of it like a super strong pressure cooker. Heat generated by fission in the reactor core is used to heat water, which turns into steam. This steam drives a turbine just like in a coal-fired power plant. The spinning turbine powers a generator which produces electricity. The electricity generated is then sent through power lines to our homes, schools, and businesses. It's the same electricity that powers our lights, computers, and everything else we rely on. But what about safety? Nuclear power plants have multiple layers of safety measures in place to prevent accidents and protect people and the environment. Let's explore those next. Section 6. Safety first. Safeguarding nuclear power plants. Safety is a top priority in the design, construction, and operation of nuclear power plants. These plants are equipped with multiple layers of safety systems to prevent accidents. The reactor core is housed within a massive containment structure made of thick, reinforced concrete and steel. Cooling systems are crucial for removing heat from the reactor core. Nuclear power plants are also equipped with sophisticated monitoring systems that constantly track reactor conditions. In the event of an emergency, detailed emergency plans are in place to ensure safety. Now that we've covered safety, let's dive into the advantages of nuclear power. Section 7. The upsides of nuclear power: clean, reliable, and powerful. Nuclear power offers several advantages as a source of electricity. It's a clean energy source, it's reliable, and it's incredibly efficient. Let's break it down. Unlike coal-fired power plants, nuclear power plants don't produce greenhouse gases like carbon dioxide. This makes nuclear power a crucial tool in the fight against climate change, helping us reduce our carbon footprint. Nuclear power plants are incredibly reliable, operating 24/7, regardless of weather conditions. This reliability makes them ideal for providing baseload power, ensuring a steady and predictable supply of electricity. Nuclear power is incredibly efficient. A small amount of nuclear fuel can generate an enormous amount of electricity, reducing our reliance on fossil fuels and minimizing environmental impact. But nuclear power also comes with its share of challenges. Let's explore those next. Section 8. The downsides of nuclear power: challenges and concerns. While nuclear power offers significant advantages, it also presents challenges and concerns that must be addressed. Let's take a look. Nuclear power plants produce radioactive waste, which requires careful handling and long-term storage. While the volume of waste is relatively small, it remains a challenge that requires ongoing research and innovation. Although accidents at nuclear power plants are extremely rare, they can have significant consequences. The accidents at Chernobyl and Fukushima serve as stark reminders of the potential risks associated with nuclear power. Building a nuclear power plant is a complex and expensive undertaking. The high upfront costs and lengthy construction times can be a barrier to wider adoption of nuclear power. The materials and technology used in nuclear power can also be used to develop nuclear weapons. Preventing the proliferation of nuclear weapons is a critical global security concern. Despite these challenges, ongoing research and technological advancements are addressing many of these concerns. Let's explore the future of nuclear power. Section 9. The future of nuclear power: innovation and advancements. The field of nuclear power is constantly evolving, with researchers and engineers developing new technologies and designs to make it even safer, more efficient, and more sustainable. One promising area of research is the development of small modular reactors, or SMRs. These smaller, more flexible reactors offer enhanced safety features and can be deployed in a wider range of locations. Scientists are also exploring new generations of nuclear reactors, such as molten salt reactors and thorium reactors. These advanced reactor designs offer potential advantages in terms of safety, waste reduction, and proliferation resistance. Fusion power, the process that powers the sun, remains a long-term goal for nuclear energy. Fusion reactions produce no long-lived radioactive waste, offering a potentially limitless source of clean energy. These advancements highlight the ongoing commitment to innovation in the field of nuclear power, addressing challenges and unlocking new possibilities. Section 10. Nuclear power and climate change: a potential solution. As the world grapples with the urgent need to reduce greenhouse gas emissions and combat climate change, nuclear power is emerging as a potential solution. Nuclear power plants produce no direct carbon emissions during operation, making them a valuable tool in our efforts to decarbonize the electricity sector. By replacing fossil fuel-based power plants with nuclear power, we can significantly reduce our carbon footprint. The reliability and baseload capacity of nuclear power make it an ideal complement to intermittent renewable energy sources like solar and wind. Nuclear power can provide a stable and predictable supply of electricity, even when the sun isn't shining and the wind isn't blowing. While challenges remain, nuclear power offers a significant opportunity to address climate change while ensuring a reliable and sustainable energy future. By harnessing the power of the atom responsibly, we can create a cleaner and more sustainable world. But how do we balance the benefits of nuclear power with the potential risks? Let's wrap things up with some concluding thoughts. Conclusion: weighing the benefits and risks of nuclear energy. Nuclear power offers a clean, reliable, and efficient source of electricity, crucial for global energy demands and climate change. However, challenges like radioactive waste disposal and accident risks must be considered. Ongoing research is vital for safe and sustainable nuclear power. The decision to pursue nuclear power involves scientific, economic, and ethical considerations. Informed dialogue helps us make the best decisions for our energy future. And there you have it, science fans.